Hello everyone. Let's see what we have here. We have two objects that one of them we called A has initial position of 100 meters above the ground. Also, this object has initial velocity of 20 meters per second towards the ground. The direction of y-axis is to upwards. Gravitational acceleration, of course, towards the ground with magnitude of 10 meters per second squared. Let's see the second object we called B has initial position of 0 meters, initial velocity upwards of 30 meters per second, and of course they begin their journey at the same time. We called t0 equals 0 seconds. Okay, let's see what we have to find. A. What is the position of the objects when they pass each other? We assume that there is no collision. What is the velocity of both objects when they pass each other? And we need to draw a function of v of t for both objects. And in addition, I also will talk about how we can draw the function of the position y of t for both objects. But let's see what we can do about the first three, A, B, and C. Okay, to find when or where they actually pass each other, we're going to use this formula, okay, which is position of object A, y0 of A, which means its initial position, and we know it's 100 meters. Initial velocity of object A is minus 20 meters per second. Why it's minus? Because this is vector, and the direction of this vector is in opposite direction of y-axis. That's why it's minus, okay? The same goes to the gravitational acceleration, which you can see here. Minus 10 divided by 2 will give us minus 5 times t squared. Okay, this is the function that represents the position of object A. Let's see what we can do about B. The same, we're going to use this formula. Okay, initial position, as we said before, is 0 meters. Velocity plus 30 meters per second, because the direction of this vector is the same direction as of y-axis. And the acceleration is also minus 10 divided by 2, which gives us minus 5 times t squared. So we have two functions, and when those two objects actually will pass each other, let's assume this would be like VA, okay, and this would be maybe upwards VB, they will have the same position, which means that we need to compare between y of A and y of B, just like this. Now, instead of y of t, we will substitute this expression that we got a few moments ago. You can see it here again. And of course, instead of b, we will substitute by this expression. And now just some mathematical steps. You can see that minus 5 times t squared and minus 5 times t squared can be eliminated. Also, I will take this part of expression from the left, I will move it to the right. That's how we got plus 20t. 30t plus 20t will give us 50 times t. And now we actually found the time, which means when they pass each other, but not yet. We do not know yet about the position. So we're going to use or expression for y of b or expression of y of a. Okay, I'm going to use this expression because we see that there are less parts in this expression. We're going to substitute t by 2 seconds. Let's see here, okay? Ya equals yb equals 30 times 2 minus 5 times 2 squared. Finally, the position of both objects when they pass each other is 40 meters above the ground. This is the solution for part A. Now let's see about part B. What is the velocity of both objects when they pass each other? Now, to answer this part, we're going to use this formula. Now, again, I also use this formula. However, I said that T0 is 0, okay? Now, let's substitute V0 of A by minus 20 again, because the direction of this velocity is on opposite direction as is y-axis. The same goes for the G. Okay, this is expression for velocity for any given time of t, okay, for object A. The same, we're gonna use the same formula to find function v of t for object B. The initial velocity, of course, is 30 minus 10 times t, and that's how we have those two functions that represent the velocity for any given time of t. Now we know that those objects pass each other at time of t equals 2 seconds. So we're going to substitute t by 2 in this expression and in this expression, and that's how we're going to find what is the velocity for both objects when they pass each other. When we're going to use the first expression, which is given by minus 20 minus 10 times 2, eventually we have minus 40 meters per second. Minus, which means that the direction of this object A is still, of course, towards the ground. Now, if I want to find the velocity of the second object B, okay, I'm going to use again this time t equals 2 seconds, and I'm going to substitute here, okay, because I used this expression, and we see that velocity of object B is 10 meters per second with sign of plus, which means when they pass each other, the direction of this object is still upwards. Okay, and this is the answer for part B. Part C, we need to draw the function of velocity for both objects. As you can see, it's very easy linear functions. Okay, we need only 2 points to draw the linear function. We know that when we talk about object B, the initial velocity is plus 30, and we also calculated before that when time is equals to 2 seconds, which is when they actually pass each other, the velocity of object B is plus 2, okay? Also, if you try to calculate the slope, okay, the slope is actually the acceleration, which is gravitational acceleration, which is minus 10. Okay, now let's go and see what we can do about object A. We know that initial, not acceleration, I'm sorry, but velocity is minus 20, okay? Also, we know that when t equals 2, the velocity of object A equals to minus 40 meters per second, okay? And we take those 2 points and we just adding linear function. Also here, if you try to calculate the slope of this function, you will get that the slope is actually gravitational acceleration of minus 10 meters per second square. And that's it. Okay, it's something that I decided to add, draw function of y of t for both objects. Now, if you remember, this expression is function of position for object A, and this is one for the object B. Okay, let's talk about A first. If you see that the coefficient of t squared is minus 5, which is negative, therefore this parabola is unhappy. Also, when we talk about instantaneous velocity in any given time, okay, it's just instantaneous velocity, which is v of t equals t1. Let's call t1, okay? And let's assume we're going to talk about this second time. The velocity at this point, okay, will be negative, okay? V t equals t2. Now, why I'm saying this? Because we need somehow to draw this parabola y of t. Now, as I said, this parabola is actually unhappy because of this coefficient, negative coefficient. Okay, so if I would draw something like this, now let's change the color. Something like this, okay? Now, I cannot use this type of graph because this instantaneous velocity would be positive at this point for object A. And I do know that initial velocity at this point is actually minus 20. So the slope or instantaneous slope or instantaneous velocity should be negative. So this is why I used this type of drawing, okay? This is about ya of t. At this point, of course, this is when object A hits the ground. Let's talk about B. Also, B has also negative coefficient. So which means also this one, this function also is parabola and unhappy parabola. As you can see, I decided to draw this graph. Now, why is that? Of course, I could use something like this. Okay, I could use maybe let's see, something like this maybe, but it's not possible because if you look at this point when t equals 0 seconds, the slope, which is instantaneous velocity, is negative. However, it is given that object B, when it's starting to move upwards, the velocity is upwards, which means is positive of 30 meters per second. So I cannot use this type of function, this type of drawing. However, if I'm going to use something like this, oops, what's a little bugs of this application, let's delete it. Now, if I'm going to use, let's delete this also, if I'm going to use this type of drawing, okay, I can see that the slope, instantaneous slope, or we can say it's instantaneous velocity at this time is positive, which means this is actually V0 B equals 30 meters per second. Now, how about this point when they pass each other? Okay, it's the position is 40 meters for both objects, and when it happens when t equals 2 seconds. Now, we found that the velocity of object B, okay, at time of t seconds of time of equals to 2 seconds, the velocity is plus 2 meters per second, which means that this slope should be also positive, as you can see. And if you look at the slope of object A when they pass each other, you can see that the slope is negative, and the value is 40 meters per second, minus 40 meters per second. Okay, and this is also time when object B came back to the ground. Well, I hope it will help you in the future to draw those functions of y of t for both objects, or even more. Okay, I'm gonna stop here. I hope I'll see you in the next videos. Thank you very much.